Right, we are looking at question 3121, 121. We have a 0.6 pound slider which move freely, mean uh, no friction between the surface of the rod and the internal surface of the slider. And this we have this fixed curve rod, and the slider move from A to B in the vertical plane, and the motion is due to the action of constant 1.3 pound tension cable in the cord, right? Tension in the cord. If slider is released from rest, mean that here velocity is zero. Our engineering problem here is to calculate its velocity v as it reach B, right here. So we have a distance from A, which is the initial state, to this pulley, right? The distance is about 24 feet inches, which is about 2 feet. And then the vertical distance of the of this cable to the center of the uh, slider is 10 feet, right? So this is a symbol of feet. But the drawing is not made to scale. So let me show you what are the solutions for this problem. So the solution of the problem given by the author is a 10 inch. I don't know whether this author or someone else will take effort to do all these calculations. And the calculation for velocity is stated at pulley location because the calculation is based on um, right. Here is AC is 26 inch. Yes, they are right. So this one is the um, 26 inches, and BC is 20. So, and the force is acting at resistance A to B about 20 inch, right? So back to the questions, we find that uh, this should be a 10 inch. As usual, we would like to find the position of the point of actions, which is here actually, right? It start from here, and then it pull down, right? And it stop when this position here, so it's some stop until here. So the this position has been travels when it stop. Sorry, when it stop at CB, position C relative to B is about 0.5 feet, and then from C to A, C relative to A, we find that is given by 2 feet, right? It's a 2 feet, and 0.383 feet, right? So the distance from A to B, from A to B is about 1.5 I in x direction and 0.83 in vertical distance. Right, so if we look at the frame the position A, I'll just take a 3 position here, so we can see the orientation of cable is changing, the constant value is changing, and this is the direction where we have a constant tension. So in order for us to evaluate with the dot product of uh, F and distance travels to determine the instantaneous work, it can be very difficult to using a free body diagram. So we are using a active force diagram, and the boundary stop at C, right? So from here, the the force been applied, and uh, we have, let's say this point is moving right towards there and it stop, and it's about 20 uh, inches. So I'm just using energy balance to calculate the velocity at B, right, instead of um, and we have kinetic energy changes plus potential energy changes. We have the net work, which is work done by the surrounding to the sliders. Work out means the work done by the slider to the surrounding. At this time, this slider is moved freely, so there is no friction, and that will be equal to 0. Yeah. And then for work in, work done by the force 1.3 pound, and the distance uh, traveled by the collar, we have x 1.5 feet square plus 0.83 square, we get about 1.716 feet. And then we can calculate the amount of work done by the uh, external force to the slider. We get about 2.2307. So the net work will be 2.2307 feet-pound, and the potential and energy changes is 0.498 feet per pound. So when we plug in all this equation, we can get the velocity at B is equal to 13.634 feet per second.